right, so today this lesson is really about if you missed our activity day to open up chapter 4, it kind of sets the tone for um, some what trig is all about and where we're headed. So going to go through a few different things through here. We're going to start with some geometry review of those special right triangles. You maybe haven't done a lot of that lately, but it's a big deal in trigonometry. So in geometry, you had two special right triangles. One of them was a 30, 60, 90. And then you also had a 45, 45, 90, sometimes called an isosceles right triangle. Now, if you will recall that in a 30, 60, 90, you're going to have a short leg, you're going to have a long leg. This is your right angle. And then you have your hypotenuse. And the relationship always holds true. It comes from the Pythagorean theorem, but the relationship will always hold true that your short leg, if you double it, you'll end up with the length of the hypotenuse here. Or if you have your short leg measurement, if you take it times the square root of 3, that would be the length of the long leg. So we kind of base everything off of this short leg. If you don't have the short leg, let's say you have the hypotenuse, then instead of multiplying by 2, you're going to do the opposite. You would divide by 2 to get to your short leg. Or over here, if you had the long leg, you would divide by root 3 to get to your short leg length. On the 45, 45, 90, two of the legs are automatically going to be the same. That's why they call it an isosceles right triangle. And then the hypotenuse is that leg times the square root of 2. So again, if you had the hypotenuse and you were trying to get to this leg here, instead of multiplying by root 2, you would divide the hypotenuse by root 2, and that would get you this length. So keeping that in mind, if you need to peek back at those relationships, that's fine, but I'm going to kind of move ahead like, oh yeah, I remember all that. So in this first one, it's a 30, 60, 90, and I know that the hypotenuse is 10. So to get to the short leg, I'd have to divide that by root 2. I'm sorry, divide that by 2. So this short leg would just be 5 units long. And once you know the short leg, then it's easy to get to the others. So you're going to take it times the square root of 3 to get to your long leg. We don't do any decimals here. We're just adding, including or getting rid of a radical in this case. Okay, so in this one, next one, I already know the short leg gets a 7. Okay, that's the easiest scenario. If you have the short leg, you double it to get to your hypotenuse. You multiply it by root 3 to get to the long leg. All right, on this number 8 here, it looks like this one has a number on it. Number 8, I have a long leg of 6 root 3 given to me. All right, that's not too bad of a situation either because it already has that root 3. So if I'm trying to get to the short leg, I would divide by root 3, which really means that root 3 is just going to go away, and the short leg must have been 6. And if the short leg is 6, then the hypotenuse is 12 because you just double it. All right, let's do a few that are a little bit trickier. In this next one, I have a short leg that's a 5 root 3. That's not a very pretty length with that radical attached there, but that's okay. Your process is the same. To get to the hypotenuse, I'm going to take it times 2. So that's going to turn into a 10 root 3. To get to the long leg, I have to take it times the square root of 3. So if you have a 5 root 3 times a root 3, the root 3's just turn into a 3, so you have 5 times 3. That's just equal to 15 for a long leg measurement. All right, let's try again. This last one. The hypotenuse is 22 root 3. To get to the short leg, I'm going to have to divide it by 2. It's half as much, so this is going to be an 11 root 3. And then to get to the long leg, I take my short leg times the square root of 3. So again, that's going to end up with a 3. So overall, that just ends up being a 33 for the long leg. Okay, so on these, the trickiest scenario is when they give you the long leg, and it doesn't happen to have a root 3 with it. So let's look at several of these. Every one of them, I'm giving you the long leg. Some are going to come out nicer than others, but the process will be the same. To get to the short leg, I have to divide by root 3. So on this first one, the long leg is a 3. Oops. Long leg is a 3. So to get to the short leg, I have to take a 3 and I have to divide it by root 3. But then I have to rationalize. And I'm left with a 3 root 3 over 3, which then simplifies to just a root 3. So it takes a little bit to get there. Now, once you know the short leg, the hypotenuse is just going to be that times 2. So we have the hypotenuse easy enough. So the trick here is figuring out how to get from that long leg to the short leg. Let's try it again. I've got a 6 for my long leg. So I'm going to take it and I'm going to divide it by the root 3. Then I have to rationalize. And I'm left with 6 root 3 over 3. And so then the 6 and the 3 reduce to just a 2 root 3. So that means the hypotenuse is 4 root 3. All right, so let's look and see if we can figure out a shortcut to this. So in this process, every time I end up taking this and I divide it by root 3, I end up rationalizing. In the process of rationalizing, I always end up with a 3 in my denominator. Right here, had a 3 in the denominator. And in the process of rationalizing, that root 3 has landed on the top. So how about if we just do that? We end up, if we take our long leg, it's always going to end up being divided by 3 and multiplied by root 3. So if you think about this 3, divide it by 3 is a 1, multiply by root 3, there you go. Take your 6, divide it by 3, and then multiply it by root 3. All right, now I started with a couple that were going to work out really nicely because they were multiples of 3. It isn't always going to play out that way, but the process will always be that way. So in this next one, I have a 10 for a long leg. I'm taking the 10, I'm going to divide it by a 3 and multiply it by a root 3. And so there it is. And I don't have to go through all that process of rationalizing. So on the next one, 4 is the long leg. I'm going to divide it by 3 and multiply it by a root 3. Now notice how I'm writing these, that I don't put the times root 3 out to the side. I just incorporate it up in the numerator. So it's just a single term there. All right, what do you think my last one's going to be? 8 root 3 over 3. Okay, and then of course on all of those hypotenuses, I should have maybe gone ahead and done those, but let's do them now. So the short leg on that first one was a 10 root 3 over 3. If I take that times 2, that's like a 2 over 1. So it's going to turn into 2 root 3 or 20 root 3 over 3. This next one, take it times 2. So that's an 8 root 3 over 3. Last one, take it times 2. That's a 16 root 3 over 3. All right, I'm ready to move on. Let's talk about the 45, 45, 90s. Now, what's nice here is 2 of the legs are always the same. So if you know one, then you know the other. And then you take that leg times root 3 to get to your hypotenuse. I'm sorry, times root 2 to get to your hypotenuse. I guess I've always remembered that 2 of the sides are the same. So the root 2 goes with the 45, 45, 90. That was always my trick in my head. All right, so on this next one here, I have a 5 root 2. It's on the hypotenuse. Since I have the hypotenuse, then I'm going to divide by root 2, which is going to play out really nicely to get to the legs. All right, same deal on this next one. The hypotenuse is already a 3 root 2, so just divide by root 2 to get the legs. All right, on this next one, I'm giving you the leg. I know the other leg will be the same. Now, to get to the hypotenuse, I have to multiply by root 2. So think about what that's going to look like. 8 root 2 times a root 2. This just turns into 2. So 8 times 2 is 16. Now that worked out nicely because the root 2's were kind of easily handled. Let's look at this last one here where the hypotenuse is a 9. And to get to the leg, I have to divide by root 2. Well, that's not going to play out nice. So then I have to rationalize it. And so then I have 9 root 2 over 2. And remember our pattern that we learned on the 30, 60, 90s, where you ended up dividing by 3 and multiplying by root 3? This is sort of the same idea, only it's with 2's instead of 3's. You end up taking that, dividing it by 2, multiplying it by a root 2. And so this right here is the length for both x and y there. So this number 20, I didn't change that out. This is the same one we just did. So let's go to the next one. It's a 2 root 10. Okay, I have to divide by root 2 to get to the leg. Now this actually plays out very nicely because it's a root 10 divided by a root 10 or root 2. Now I could try to rationalize it, but let's just use the properties of those radicals right there. That can actually reduce. A root 10 divided by a root 2 is just a root 5. So I would have a 2 root 5 for the 2 legs on this one. All right, on our last one, it's not going to divide by root 2 nicely, but I'm going to use my shortcut of instead of dividing by root 2 and then having to rationalize it all, I can just take that hypotenuse and I can divide it by 2, multiply by root 2. So divided by 2, multiply by root 2. Divide by 2, multiply by root 2. So just 5 root 2. All right, so you have a worksheet where you have 30, 60, 90s on one side, 45, 45, 90s on the other, and then there's a few that are merged together at the end. So that's part of your homework is to work on that worksheet and get that completed. All right, so on our activity day, after we talked through the special right triangles, we started our activity of looking at circles, circumference, radius, looking at relationships and angles. And so there was a whole worksheet. I'm just doing the recap, so I'm not redoing the whole activity. Now, on that activity, one of the things, number 4, the question was, what is the ratio of the circumference to the diameter? All right, so when you were measuring your circumference of your can, you had a can that when you measure the circumference and then you divided it by the diameter, in a perfect world, you would have gotten a ratio of 3.14. So how close were you to the 3.14? What do you think that was supposed to end up being? Yes, it should have been pi. So you can look at your answer and see how close were you to pi. And that did not matter if you had a small can, big can. The circumference divided by the diameter should always end up equaling pi. And that's actually the definition of pi. Pi is the ratio of the circumference to the diameter. Now that's important to remember what pi is. It's not just some magic number. It is always, that's where it comes from. It is always taking the distance around a circle and dividing it by its diameter, and it should always be pi. There's a little sticky note because that's going to be quizzed on later. You have to know the definition of pi. Okay, so you've learned that you can measure like with centimeters or inches. You can do temperature in Fahrenheit or Celsius. Angles actually have 2 different, well, actually they have more than 2, but 2 that we're going to deal with, ways to measure different types of units. And you've always measured angles in degrees. But now we have a new type of measurement, and it's called radians. That word radian comes from the word radius. So what we did in our activity is we had our circle here, and we took a piece of string and measured that radius, and then you took that radius, that string that was the same length of the radius, and you curved it around the circle, and then you marked it right there. That, when you make the arc length the equivalent to your radius, you've created an angle inside that circle. And that angle measurement right there is called 1 radian. So you can see that's much bigger as compared to like 1 degree. A radian is closer to like it's a 57 or 58 degrees is about how big that is. It's not a nice, perfect conversion, but you need to then remember what a radian is. And I got another sticky note, means you're going to get quizzed on this. You need to know this definition, and this needs to make sense to you too. I almost want you to know it verbatim, word for word, but when I quiz you on it, there's two things I want you to acknowledge. I want you to know that it's a way to measure angles. So 1 radian is the measure of a central angle. So the way we measure angles. But it's also very important to understand that that 1 radian happens such that your arc length created is equal to the radius of your circle. And so this is that picture I just drew on the previous slide. As soon as you can get the arc length to be the same as the radius, you've created an angle in there. We use Greek letters in trigonometry. This is the letter theta, and that represents, in this case, 1 radian. So the next part of our activity is then we were trying to take that and not just make 1 radian like we did. We wrapped it around to here. We took our string and we wrapped it, and then we wrapped it, and then we wrapped it, and we kept wrapping it all the way around, okay? And seeing how many times we could do that in one circle. And so then the question on number 10 was, how many times were you able to do that? And the answer should have been 6. And was it exact? And your answer should have been no. No, it does not actually play out to where that string fits perfectly on your circle 6 times. So as usually what happens is some people, they made it work out perfectly 6, mostly because they wanted it to work out perfectly 6. And so they kind of fudge it enough to make it work. But if you're very, very precise, you will learn that when you're doing that and you're making that circle, what you are able to do is you're able to wrap that string once, twice, 3 times, but not quite make it all the way around. So it landed something like this. That would have been 3 radians. There's 1, 2, 3. And then there was just a little bit left over before you were straight across on that, which means by the time you got all the way around, you were off a little bit more. Let's see. Let me get back to my questions. 12, making the arc length equal the radius. Use your protractor to measure that angle. Ideally, you were around a 57 or 58 degrees. And it does say label it because you need to know that that's in degrees we're talking, not in radians. Which takes us to this diagram, which is way better than the one I was drawing. So what we have here is, this is what you're used to. This is nice geometry. You have a semicircle. It's 180 degrees. Got it. Over here, you had 1, 2, 3, and a little bit more to be equivalent to that. Turns out that 3 radians and a little bit more, that little bit more is not random. That is that 0.15159, which really means that 180 degrees is equivalent to pi radians. Super important to recognize. All right, so when I'm talking degrees, that's 180. When I'm talking radians, it's pi radians. So a little bit more than 3 radians. And pi doesn't really convert perfectly to anything. So that's why we typically leave radians in terms of pi so that it kind of comes out a little cleaner. One of the places that you maybe would have seen this and where this might make sense is that when you were doing circumference of a circle. In my picture here, I have this radius, and I'm never going to make this come out perfect here. I'm going to try. See if I can. There's 1 radius, and then I put another radius, and then I put another radius, and then remember, and a little bit, which means that's pi. But I'm just going to really keep going. So if it's pi halfway around the circle, would it make sense then that all the way around the circle would be 2 pi? So what I have done is I have taken this radius and I have wrapped it around once, twice, 3 and a little bit, 2 and a little bit more. I've wrapped it around 2 pi times. So to find the distance around there, I would take the radius and I would multiply it by 2 pi, which should look familiar as your circumference formula. All right, so that's sort of where that's coming from. All right, so that was sort of the end of the activity and some ideas that we're going to keep coming back to. Now what we're going to do, because we're going to use several angles, they're very common, they pop up all the time. We need to get to know both degrees and radians of different angles. We call this our unit circle, and ideally you have a copy of the unit circle where you can just put these values on that. You don't have to put this in your notes if you have a unit circle to put it on. So I'm going to color code because this unit circle that we have is going to have like 5 things written at every single dot. And so that will be a lot to fit on. So I'm going to color code. I'm going to go with red. And what I want to do is I want to put the degree measurements, some very common degree measurements on this circle. So first of all, I think what we've already talked about is if you go halfway around the circle, you're at 180 degrees. If you go all the way around the circle, you'd be at 360 degrees. Now be sure you put your label on this. This is in degrees. Later, we're going to come back and do radians. Now, really, I should start with at the very beginning, this first dot, and we always start over here on the right because we think of it like a protractor, where you're starting here and then you start measuring the angle around. So this is really 0 degrees. But once you've taken that angle and you've wrapped it all the way around, that's a 360 degrees. Those are not considered the same angle. They just happen to land in the same place. All right, let's put in some other easy ones. Let's just put in a 90 degree. We should know that. Straight up would be 90 degrees. So these are called the quadrantal angles. They land on the axes. So you have a 0 degree, 90, 180. What do you think this one straight down is? All right, 270 degrees is what that would end up equaling. All right, so now the next thing I'm going to fit in is I'm going to fit on all the 45s. So that's the one that cuts that quadrant right in half. So this first one is 45 degrees. And then I just start wrapping around, not percent, where did that come from? 45 degrees. And then I'm going to add another 45, and that's going to take me to 90. Add another 45, and you're going to be at 135 degrees. Add another 45, and you're at 180. 180 plus 45 takes me to 225. Straight down is 270. And then another 45 would take me to 315 degrees. So those are all of your 45 measurements. Then what we have is we have this broken down into 30 degrees. So right here is 30 degrees. And then you can see these are a little bit closer because it goes 15, 15, and then 30. But really what we're looking at now is we're looking at this 30, and then another 30, and then another 30. And so we're kind of ignoring those 45 marks in there. So let's go around. Here we go. First one's a 30 degrees. Plus another 30 is 60. Plus 30 takes us to 90. The 90 plus 30 is a 120. Plus another 30 is 150. Plus another 30 takes us to 180. And let's take 180 plus 30, that's at 210 degrees. I know in geometry, we always stopped at 180. Not here. We wrap all the way around. In fact, we're going to wrap around multiple times sometimes. All right, 210 plus another 30 is 240 degrees. Plus 30 takes you to 270. Plus another 30 is 300 degrees. And then a 330. And then your 360 back where we were. All right, so part of your homework tonight is going home and studying this so that when I say point to a 210 degree angle, you immediately know, oh, that's down here. This is a 210 degree angle. Or if I say 315, you know, oh, that's this one over here. So let's talk about a few things that might stand out to help you remember that. First of all, if you look at all the 45s, they all end in a 5. Nothing else ends in a 5. So if I ask you about an angle and it ends in a 5, you should automatically think, all right, that's going to be one of the 45s. Now, to figure out which 45, I always have noticed that up here in the first quadrant are 2-digit numbers. These are all your small numbers. But then here are your 100s, 200s, 300s. So that also can help you get in the right place. If I say 225, well, it ends in a 5, so it's a 45, and the 200s are all down here. So that's going to be my clue. All right, you will get to know these very well because we just do it all the time in trigonometry. But I will promise you, the quicker you learn them, the easier your life will be. So commit the time early on here to actually do some studying every night and know where these angles fall. Because now we're going to do it with radians, and this is going to get trickier. So that's why the degrees are so important. Get that down. That's the easy stuff. And even the radians are going to end up easy. All right, so I'm going to a different color. Again, put this on your unit circle rather than in your notes if you have it. Okay, so starting with what we've already talked about, going to go around and put radian measurements on all of these. I might put these on the inside since the degrees are on the outside. So this is still considered 0 radians. Now, remember we said that if you go all the way around to the 180 mark, that's 3 and a little bit radians, and specifically that's pi radians. So I'm going to put a pi here. If you don't put any label, we assume it's in radians. The degrees have to have the little circle. All right, so I just write pi there. And if I went all the way around, remember that was 2 pi. So now you think proportionally what's going on. You kind of think at how close to pi are you? So I'm thinking, all right, well, when I get up here to this 90 degrees, when I'm straight up, I am halfway to pi. So what that means is it's 1/2 of pi. We write that as a pi over 2, though. We combine that into 1. Now, if that's half of pi, then every 90 degrees is another half of pi. So there's 1/2, there's 2/2, which is 1. Straight down is 3/2, so I'm going to write that 3 pi over 2. And then up 4/2 would be your 2 pi. Let's try it again. Let's try it with the 45s. If you are right here at 45 degrees, think about what portion of the way you are to pi. Well, if 90 was halfway, 45 is going to be 1/4 of the way. So here we go. That's going to end up being pi over 4. And now I just start counting off fourths. That's 1/4. Straight up would be 2/4, but that reduced to pi over 2. Already got it. So the next one is going to be 3/4. 3 pi over 4. And then 4/4 takes us to pi. Keep going around. Here's 5 pi over 4. Straight down would be 6/4, which is already reduced and already there. So that means over here is 7 pi over 4. And then it lands you at 8 pi over 4, which would reduce to 2 pi. So your 45 marks there, notice those are all broken down into fourths because you're 1/4 of the way to pi. All right, so let's try the same idea with the 30s. I am at 30 degrees right here. What portion of the way to pi would I be? One way to think of it is 30 is what portion of 180? And ideally, it comes to you as, oh, that's a 1/6. So that means if I'm a 1/6 of the way to pi, then this is pi over 6. And so then all the way around as I go, it's every 6. Keep adding another 6. So at the 60-degree mark, that'd be 2/6. But I do want to reduce that. I don't want to write 2/6. I would reduce that to 1/3. So that's just a pi over 3. Straight up would be 3/6, which reduces. So that means this one is 4/6. But 4/6 reduces to 2/3. So we write that 2 pi over 3. And if that's 4/6, the next one would be 5/6. So 5 pi over 6. and then 6, 6, which is just 1 pi. So this one down here is 7, 6. And the next one is 8, 6. But 8, 6 does reduce. Straight down is 9, 6. But 9, 6 actually does reduce to 3 halves, so it's already taken care of. So that means this one is 10, 6, and this one's 11, 6. But 10, 6 would reduce to 5 pi over 3. And then this one is 11 pi over 6. And there we have it. It's all filled in. So the next level, after you have those degrees figured out, now you're doing the radians. And you have to be able to think through. Notice I say think through the radians. It's not like memorizing it. I'd rather it just kind of makes sense to you in your head of where we came up with those. Of course, there are some patterns that you might notice. Like I said earlier, if I give you something like 7 pi over 4, the fact that it's over a 4 would clue you in that it's one of the 45s. And then 7/4 is pretty big, so it's going to wrap around quite a ways before you make it to a 7/4. It's taken me to that third quadrant. If you feel like you want to count that out and just think, okay, I know it's a 45, so there's a 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. Do something like that. Now, it would be helpful, though, if you're going to do that and kind of count that out like that. And I do it, so don't feel bad if that's your method. That's great. But it would be nice to be more efficient about it. And rather than starting with a 1/4, can we all agree that here I would be at 4/4? And maybe you just start from 4/4. And then you go 5/4, 6/4, 7/4. And you've got yourself figured out where that falls. Okay. The other thing, if you look at the 30s, you're counting by 6. So you could go 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. But here again, 6, 6. So if I give you something bigger than 1 pi, if I give you, let's say I give you 11, 6 or something, I would start off and count with, okay, there's 6, 6. 7, 6, 8, 6, 9, 6, 10, 6. There's my 11, 6. If you end up with something that's a third, well, that just means that it was one of the evens that reduced. So like right here was 8, 6. So if you land at 8, 6, then you have to reduce it to a 4 pi over 3. But conversely, if I give you 4 pi over 3, in your head, you may want to bring that back up. Okay, that's an 8, 6. So where would an 8, 6 be? Well, 6, 6 is right here. So then 7, 6, 8, 6, it's this one down here. Because ideally, again, I am hoping that I'm going to be able to say point to 5 pi over 6 or point to pi over 3, and you just immediately know where that's going to fall. And eventually we're going to then get the conversion, like when I or like this, if I just point to a spot, I point to right here. Do you know what that is in degrees? Do you know what that is in radians? And this is going to become old hat, I promise, but only if you study it. And if you put it off and put it off, everybody else is going to bypass you and you're going to find yourself floundering in about a week. So, got to commit early on. Study it, figure it out. All right, so that's all I've got for us. That's the end of the recap. Let's go ahead and, I guess, go work on that triangle worksheet and study that unit circle.